myalgic encephalomyelitis, chronic fatigue syndrome. Blame it on mitochondria, not hypochondria. The key feature of ME/CFS is post-exertional malaise. This is a fancy way of saying that when patients with ME/CFS push themselves beyond their energy envelope, they crash and their symptoms get worse. We now know that this is in large part due to a problem with mitochondria. So what are mitochondria? Mitochondria are the powerhouses of the cell. They generate most of the cell's energy supply, ATP, or adenosine triphosphate. There are up to 2,000 mitochondria in a single cell. Mitochondria use glucose, which is a sugar, and other nutrients to generate energy. They burn the glucose with oxygen to create energy and two byproducts, water and carbon dioxide. The body gets rid of the carbon dioxide by breathing it out. If the mitochondria are sick, they have a limit to energy production and they take longer to recover. What makes the mitochondria sick in ME/CFS? One reason is oxidative stress from free oxygen radicals. That's why some patients do better with antioxidants. Another reason is that the immune system can damage mitochondria, attacking them as if they were enemies like bacteria or viruses. During an activity, the body produces energy using oxygen. We call this aerobic metabolism. But there are limits. If the body can't produce energy fast enough, it switches to anaerobic metabolism, meaning without oxygen. This is a less efficient way of producing energy than when oxygen is used. Worse, the byproduct of anaerobic metabolism is lactic acid, which accumulates in muscles rather than being breathed out like carbon dioxide. There's a limit to how much lactic acid the muscles can accumulate before you run into problems. For example, the cramps you feel if you exercise too hard comes from lactic acid buildup. Another issue is patients with these conditions take longer to get rid of lactic acid from their muscles. The reason why marathoners can run for so long is that they burn oxygen slowly and efficiently through aerobic metabolism. Sprinters, on the other hand, rely on a quick burst of all-out energy through anaerobic metabolism. This graph may help you better understand. If you do a bit of work, you use a bit of oxygen. As you continue to push yourself, you use more and more oxygen, but there's a limit. At some point, you can't increase your oxygen consumption. This is called VO2 max. This is the maximum amount of oxygen you can use before switching to anaerobic metabolism. It turns out that your heart rate is a reasonably good indicator of oxygen use. You may have seen some of these charts at the gym. Your maximum heart rate is 220 minus your age. Most healthy people switch to anaerobic metabolism when their heart rate gets to around 80% of their maximum heart rate. For instance, a 40-year-old woman has a maximum heart rate of 220 minus 40, which equals 180 beats per minute. 80% of this is 144 beats per minute. That means that when her heart rate gets to around 144 beats per minute, she no longer can produce enough energy using oxygen and goes into anaerobic metabolism. Athletes can push even further before they stop using oxygen. Individuals with ME/CFS have a lower VO2 max. They switch from using oxygen to not using it at a lower heart rate because they are deconditioned from not being able to exercise. This happens at the heart rate of 60 to 70% of maximum. But there's more to it than simple deconditioning and achieving VO2 max at a lower heart rate. When people with ME/CFS are in a crash, their VO2 max drops even lower. Their ability to use oxygen for metabolism gets even worse. We can see this with treadmill testing. If people do a treadmill test to their maximum capacity for 2 days in a row, we get a better idea of abnormal oxygen use in patients with ME/CFS. When you compare normal individuals with patients with ME/CFS, there are differences with their peak oxygen use, which is their VO2 max. For people with ME/CFS, you can see that their ability to use oxygen is diminished at baseline due to deconditioning. For normal individuals, their ability to use oxygen doesn't change on the second day. But for patients with ME/CFS, their ability to use oxygen decreases by half because they are in post-exertional malaise. Exercising to maximum capacity on day 1 pushes them into that post-exertional malaise, or a crash. A recent report by the Institute of Medicine paid special attention to the post-exertional malaise experienced by people with ME/CFS. They suggested upgrading ME/CFS from a syndrome to a disease. The name they suggested was Systemic Exertion Intolerance Disease, or SEID. Although the name hasn't caught on, the report has been instrumental in raising awareness and interest in this disease. Major journals and government funding agencies have responded positively. Hopefully, this will translate into better care for patients and more research.